This is a tutorial video for using the hardware simulator, which is located under Core Hardware Simulator. Before showing the usage, I want to make 2 points. One is if you're using the simulator to test anything involving Yondr and remote picking, you'll need to be set up with all of the AWS credentials that you need to use the cloud stack. If you're using Yondr, you probably already have these. If not, Dan is the one who usually sets these up. The other note is that the simulator right now is based upon Jinsoku, which is a little out of date compared with packing or just the generic Pick One Yondr application. So some of the functionality, especially in bowls, is going to be a little out of date. After we finish setting up the MH5 here in Boulder, I'm going to be porting the simulator over to that, which will use the most up-to-date Pick One software. That's something to keep in mind. So in order to use a hardware simulator, there's basically two ways to use it. One, if you just want to test Yondr functionality in the cloud or Click One, and another is if you need to change the actual any C++ code and do testing on that. However, if you're just doing Yondr, firstly, basically just follow this instructions here. So once you have all your credentials set up, you clone the simulator, go into it and just pull Docker Compose up. Unfortunately, there's a slight typo. Here it says Docker Compose Jinsoku Yondr. It's actually just Docker Compose Jinsoku. So basically, once you're in the hardware simulator directory, you can just call Docker Compose-F with this and then up. As a quick note, if you have used a hardware simulator before, make sure you do a pull to get the most recent version of all the images. But once you do that, you can do Docker Compose up. This will start the Bowls GUI, the Kitsune web bridge, and basically the entire Jinsoku application. So unfortunately, it takes a little while for everything to load up here. This is Jinsoku loading everything. And then, so we'll wait for that to finish for a minute.
So I'm also correcting that to output the proper extension. That's what I was looking at. So I'm doing.
Okay. So once that's done, you can, again, if you want to use Yondr, want to test Yondr, you need to run rqt reconfigure. And that will allow you to change the controller pick point parameters, force remote pick count. So -1 means it'll never force remote. If you always want to force remote, just set it to 0. And then that'll basically force it to call out to Yondr. So at this point, if you start up the Bowls GUI, which is at localhost 3000, you'll see the simulated images. And then you can basically clear and reset the state machine. And you can see here that the output from the Docker container. As a quick note, you'll probably see when you're running the simulator a lot of these WebSocket closed error. This is a known issue that doesn't affect the running of Bowls GUI, but it is a little annoying. So in either case, once it has reset, we can start the robot going and then go to the Click One, whichever Click One stack you're using. And if everything is configured correctly, you should see the image here. And then you can select that, and you can see that the robot is doing a pick and place. So that is the Yondr workflow. Clearly it sends up images and you can see everything in the cloud as well if you look at the AWS console. And then it'll just continue to force picks until you stop it. So I'm going to stop that demo and show now what to do if you actually want to test some code in the application, for example, Kitsune. So here you'll run through this kind of second use case. And basically, so again, you start by cloning and going into the hardware simulator. Instead of running the entire Docker Compose with the Bowls GUI, the Web Bridge, and Jinsoku, we're just going to run the Web GUI. So this is going to spin up the Web GUI the Bowls GUI for us. And once it's all loaded up, it'll be set up, and there's no feed because we're not running the actual application yet. So what we want to do now is just run a little script called run local, which is, instead of launching the Jinsoku application as an image, it's going to launch it as a container that we're going to go into so we can make changes. So if we run local, so you can now see we're in a Docker container, which has, most importantly, the Catkin workspace. And then if you go into Catkin workspace, you can see there's source, and then all of our usual packages are here. So if you wanted to change it, you'd go into source +1 robotics Kitsune, and then pull down your most recent changes, or something like that. In either case, once you've done that, you just need to source the workspace, and then basically running the same command that the Docker Compose up file ran, but within the Docker itself. So again, this is going to take some time, but this is spinning up the entire Jinsoku application. So we'll give this a minute to start up. Okay, so then it's about done, and now we can go back and see that we're actually using the simulated video stream, and we can use the state machine just like we saw with the Yonder use case. So here we're going to the home position, and once that's done, since we haven't made any changes to RQT reconfigure, this is just going to do basically pick in places back and forth forever. So in either case, that is kind of the second use case for using the hardware simulator. Again, if you want to change code within the actual Docker container. So that's about it. If you have any more questions, feel free to reach out to me on Slack. Thanks.